Mining information from social media. In this lecture, we will consider some information regarding behavior and techniques for mining information from social media. The basic topics will be classification of social behavior, link prediction, viral marketing or outbreak detection, network modeling, and social dimension. Now, first we will classification of social behavior. First is user preference or behavior can be represented as a class. It will clear from following example. For in a given web page, how we can classify or label the social behavior. Suppose we have some web page and we have provided some advertising at the corner of the page or at the end of the page. And we can classify the user behavior by just checking whether user click on such ads or not, whether or not interested in certain topic, whether likes or dislike the product, or so on. Similarly, in social networking sites, comments by friends, likes or dislikes of any post or a status. Suppose you have a Facebook account and you post some message and some friends comments on them, some likes or dislikes on them. So you can make a label like as a comment, as a make a comment. You can use comment as a label or like or dislike on post as a label, and so on. Similarly, in commercial websites, like or dislike of product, views towards the products maybe may represent different labels which can be used to classify the behavior of user in social network. Now this is another how you can predict something in social network just by using visualization. For example, suppose you have a network where blue slides represents people who smokes people who smoke, and green slides non-smoking people, and for black it is unknown. But based on the network, is it possible to predict something? Yes. Then how can you predict? For example, link 7 is related to link 11 and link 6, so it will be influenced by link 11. So it may be 7 may be non-smoking because it is near to the node non-smoking. Similarly, link 6 will be non-smoking because it may be influenced by node 5. Similarly, node 9 may be non-smoking because it will be influenced by node 13. Node 8. Now node 8 node 8 has two connections, node 12 and node 1, which are smokers, node 13 which are not smokers, non-smokers. so it will be influenced by majority. So node 8 will be smoking. Similarly, node 10 will can be predicted as a smokers. So this is the prediction, final prediction. Now another simple example for link prediction. In the previous example, we predicted the behavior of node by using the behavior of adjacent neighbors, or strength of adjacent neighbors, means count of adjacent neighbors, etc. Here, how can we predict the link? Given a social network, predict which node are likely to get connected and output a list ranked as a pair of nodes. For example, friend recommendation in Facebook. How it works? For example, in this network, how many link predictions is possible? Link predictions are possible. First is 2 and 3. 2 and 3 may be connected. 4 and 12. 4 and 12 can be connected. 5 and 7, there may be a connection between 5 and 7. 7 and 13. How can we predict such kind of links by just watching some network or social network? There may be several methods. For example, we can use the clustering coefficients, which can improve the clustering coefficients of the network. We will try to add such kind of link. Another thing is, suppose we can just identify the which nodes are which have more common number of links between them. We will predict such nodes as a friend. For example, here also 5 and 7 have one common link, but 11 and 5 don't have any common link. So before adding this link, so we cannot predict 5 and 11 as a friend, or we can predict a link between 5 and 11 because there is no common link or common node between 5 and 11. Now the next topic is the viral marketing or outbreak detection. Users have different social capital or network values within a social network. Hence, how can we make the best use of this information? Viral marketing, outbreak detection. Viral marketing means find out a set of users to provide coupons and promotions to influence the other people in the networks, so my benefit is maximized. The main goal of viral marketing is to reach the maximum number of actor or node or members in a social network by using minimum cost. Viral marketing is very important. Suppose you are a new businessman and you want to reach a maximum number of people to improve or increase your business, then concepts based on behind the viral marketing will be very useful and for advertising. Now this is a viral marketing is an evolving field for Web 2.0. Second is outbreak detection. Monitor a set of nodes that can help or detect outbreaks or interrupts the infection spreading. For example, Social networking can be used for such kind of outbreak detection. How? And by using this information, we can prevent the spread of disease or such kind of epidemic disease. Here the main goal is, given a limited budget, how to maximize the overall benefit. An example of viral marketing. In this example, we just use the concept of centrality. For example, find the coverage of whole networks of node with minimum number of nodes. Find the coverage of whole network of nodes with minimum number of nodes. How to realize it? An example, I used a basic greedy selection based on some centrality measures. Select the node that maximizes the utility, remove the nodes, and then repeat. For example, in this graph, we selected node 1. After that, we select node 8. After that, we select node 7. Node 7 is not a node with high centrality. In this scheme, we use the concept of centrality. And just applied a greedy approach to select the next node having high centrality and which covers the rest of the nodes, and so on. There are several other methods which can be used for viral marketing, like linear threshold model, with some flexibility, and linear cascade model, and a hybrid model can be used for viral marketing also. Those models are already discussed in previous lectures. Now the next topic is the network modeling. How can we model the networks? The first one is large networks which demonstrates some statistical patterns, can be modeled by using small world effect, 6-degree separation, power law distribution, and community structure, already discussed. Now, how we can model the network dynamics? For this, find a mechanism such that the statistical patterns over a large scale networks can be reproduced. For example, random graph, preferential attachment process, etc. Now the next is the used for simulation of simulation to understand the network properties. For example, Thomson-Schilling's famous simulation scheme. What could cause the segregation of white and black wool? Network robustness under attack can also be used for network modeling. Here some graphs representing the comparison of networks model, observation over various real world large scale networks, and outcome of a network model. It represents some fluctuations, some limited growth, limited downfall, some uncertainty, but so the final outcome of a network models can be given like this. This is also cleared in the example of random networks and scale-free networks, where random networks can be represented through a straight line. Scale-free networks can be represented by using bell-shaped curve. Now the next topic is the social dimensions. What is social dimension? First, we will consider the following points. For example, affiliations of actors are represented as a social dimensions. Each dimension represents one potential affiliations. Social dimensions capture prominent interaction patterns presented in the network. For example, this affiliation, for example, in this network, there are two actors, especially marked actor 1 and actor 2. In this affiliation, two actors especially marked actor 1 and actor 3. Now the important thing is the affiliations may be some group, some property, or some activity, etc. So suppose this actor 1 suppose this actor 1 and actor 2 all related to affiliation 1, and affiliation 1 represents a non-smoker group. Similarly, in affiliation 2 represents vegetarian people. Then we can find that actor 1 is common in two affiliations. Actor 2 is related to only non-smokers group. Actor 3 is related to vegetarian people, and so on. So it is clear that every affiliation represents some particular property or interaction patterns which binds the actors to a certain group, and each such affiliation can be represented as a dimension. There may be some actors which are common in multiple affiliations, and each dimension, this can also be represented as a dimension. Each dimension represents one potential affiliation. Now approach to social dimension approach. Suppose this is a network. How can we identify the social dimension? Extract the potential affiliations from this network. We will extract all potential affiliations. This will be the social dimensions. We will label them. Extract social dimensions to represent potential affiliations of actors. Any community detection method is applicable. For example, block models or spectral clustering can be used here. because there is a relation between multiple such levels, or this is an example of heterogeneous network or multi-mode network. So we can use the spectral clustering or block model. After that, we apply training, build a classifier to select those discriminative dimensions. Any discriminative classifier is acceptable, for example SVM, logistic regression, etc. Now predict those levels based on the actor's latent social dimensions. Training, predictions, classifier, and then predicted level. No collective inference is necessary. Now the underlying assumption is, for example, apply the community detection. Community detection, we can identify the communities: Democratic Party, Republican Party, Catholic Church. Now there is some addition or deletion, so apply the supervised learning to identify the all such affiliations. Assumption at the level of one node is determined by its social dimension. PYI, this is a probabilistic, how it is related to some dimension, or how it may be related to some other dimension. The community membership here served as the latent features. And these techniques are used here to identify the levels of the social dimension. Thanks.